This is section 11.8, volume of spheres. So the volume of a sphere is 4 pi r cubed over 3. So we're going to have to be using buttons on our calculator that either look like this, or maybe this, or like a caret symbol, like you're inserting something. Most calculators look like one of these three. There's possible you have one that looks different. That's okay. But these are the three main ways. So we want to find the volume of the sphere. My radius is 7. So we're going to do 4 pi 7 cubed over 3. So I'm going to start by doing 7 to the 3rd power times 4 times pi. Again, you can divide by 3 in this step also. I don't know why I don't. Just habit. My overall volume for this problem would have been 1,436.8 inches cubed. Here's a check-in for you to try. Pause. Answers are posted on Google Classroom. For example 2, we have another sphere, but this time we have the diameter instead of the radius. So I'm going to divide this 33 in half. And I know it's the diameter because they drew the line all the way across. So my radius is really 16.5. So now my volume, 4 pi r cubed over 3. I have 56,449.7 over 3. So I got 18,816.6 cubic centimeters. There's one for you to try. Pause. Answers are posted on Google Classroom. This shape, which is half of a sphere, is a hemisphere. So if I took the formula for volume of a sphere and took half of it, the bottom is really now going to be 6, and 4 over 6 can reduce to 2 over 3. So I'm just going to tell you we're going to use the volume of a hemisphere is 2 pi r cubed over 3. That's what we're going to use to find our volume. So I do see I have a radius of 5, so we're going to have 2 pi times 5 cubed over 3. So this is 785.4 over 3. So my volume was 261.8 cubic kilometers. That's a big one. So here's one for you to try. Pause. Answers are posted on Google Classroom. In example 4, a sphere has a surface area of 4,208.35 square centimeters. And they're telling me the formula for surface area is 4 pi r squared. What we really want is the volume of the sphere. So what I don't know is the radius, because that's what gets plugged in to find the volume. So I'm going to work backwards from the surface area to find the radius, and then use the radius to find the volume. So 4208.35 is equal to the formula 4 pi r squared. So if I start by dividing by 4, and then divide by pi. Some of you may have noticed you can divide by both at the same time, but it's tricky. Your calculator thinks you're trying to do other things, so you need to do parentheses around them. It's easier to just do them two separately. So now I'm left with this number. I'm going to take the square root of it. So when I take the square root of both sides, I get that r is 18.3. And now that I have an r, I can find the volume. So we're going to take 4 pi 18.3 cubed over 3. So I got 77,012.8 over 3. And dividing that by 3, I got 25,670.9 cubic centimeters. So here's a problem for you to try. You could pause. Answers are posted on Google Classroom. For example 5, Abby bought a lawn ornament in the form of a solid sphere. The glass used to make the sphere has a density of 0.09 pounds per cubic inch. If the sphere's radius is 3 inches, what is the weight of the sphere to the nearest pound? So we know that weight means mass, so mass equals density times volume. We know D is 0.09, but I don't yet know V. To find volume, we know that the radius is 3. So we're going to have 4 pi 3 cubed over 3. So I have 339.3 over 3. I get 113.1. So now my volume is 113.1. So if mass equals density times volume, if I multiply these two, I get a mass of about 10.17, so about 10 pounds. They said round to the nearest pound. So here's one for you to try. You can pause. Answers are posted on Google Classroom. So composite figures are 2 or more figures that are combined. So we've done some composite areas where we had 2 areas that we had to add together, and now we're going to do the same thing with volumes. So for an example 6a, it says identify the solids in the composite figure and then find the volume of the composite figure. So I have a hemisphere as one solid, and I have a cone as my other solid. So I'm going to find the volume of each of these separately first. So for my hemisphere, we know that's 2 pi r cubed over 3, and my hemisphere has an r of 1. I'm going to do it all at once now. I get 2.1 is my volume of the hemisphere. My cone, which is pi r squared h over 3, r was 1 and h was 5. So overall, that had a volume of 5.2. So together, my composite shape, if I add these two, would be 7.3 cubic meters. This was a small number, not always going to be the case. Let's look at example 6b. So I have a cone as one shape, and I have a cylinder as the other. So my cone, which is pi r squared h over 3, the r is the same for the cone as it is the cylinder, so that's 6. The height of the cone is 4. So I get a volume here of 150.8. My cylinder is pi r squared h. So the r was 6. The h was 5. So this volume is 565.5. So if I add those two together, I get a total volume of 716.3 cubic meters. Do another one of these together. In example 6c, I have a square pyramid on top. And we can call the bottom either a square prism, or there's a word for that. That's a cube. If you want to call it a square prism, that's perfectly fine. So for our square pyramid, we know the area of the base was 6 times 6, which was 36. The height of the pyramid was also 6. So my volume, B times H over 3. was 72. For my cube, I could do length times width times height. 6 times 6 times 6. And I got 216. So my overall volume would be 288 cubic meters. So here's one for you to try. You can pause. Answers are posted on Google Classroom. It's also possible for us to have more of a word problem with these. So a grain silo is built from 2 right circular cones and a right circular cylinder. The height of the cylinder is 12 feet, the height of each cone is 7 feet, and the radius of the cones and cylinder is 5 feet. Find the volume of the grain silo. So for the cylinder, we'll start there. We're going to have pi r squared times the height. So the volume of the cylinder is 942.5. There are 2 cones. So I'm going to find the volume of one of them, pi r squared height over 3, and I'm going to double it. So for just one cone, I had 183.3, and when I've doubled that, I rounded that, so when I doubled it, it's actually 366.5. And now I can add these two things together, the 942.5 plus 366.5. Oops. You can't see what I did, but I multiplied them. So 1,309 cubic feet. The last one for you to try is right here. You can pause, check your answers on Google Classroom. Just be careful, they're giving you the diameter of both the cylinder and the hemisphere. That is it for section 11.8.